All right, so the question we're focusing on right now was the frequently asked question that talked about why do some elements switch and some elements do not switch places. Is that right, Quay?
Yeah.
All right, didn't mean to throw you under the bus on this video or anything, but that's why you're going to go far in life, because you're getting help. All right, predicting products. So first off, you're going to have to know that not all types of reactions switch products. There's only two of them that'll switch, and that's the single and double replacement, sometimes called displacement. Those words are used interchangeably a lot. All right, so let's take a look at one of the examples. We'll look at this, this single replacement right here, number 6. In a single replacement reaction, one thing, first off, you're going to have one element by itself. That's how you know it's single replacement, right?
Yeah. The thing I
Go ahead, what's your question?
the thing I don't understand is how do you know which one switches with CA?
Okay,
Like, you know what I mean?
let's see. Well, you got to look at the charges, right? If you write everything down above it, CA has a charge of +1. AG has a charge of +1. And CL has a charge of -1. Right? And if you don't understand that, go to the how do I get oxidation numbers part. But if we look at this, your CA is going to have to switch with the AG, because in the end, you're still going to need to have a plus and a minus together.
So what's CA going with?
So what's the only thing it could go with?
CL.
Absolutely. So your answer over here is AG plus CA plus CL minus. And then you do the crisscross method, and that gives you CaCl.
Okay.
So that kind of gets rid of that. All right. So if we look at, let me kind of close out of that, we'll look at another single replacement reaction. All right, here's a single replacement reaction with Na and MgCl. I'm looking at number 8. If we look at this one, real quickly, right away, I can see that this guy is going to switch with this guy. You see how I did that?
Yeah.
Right here, I know that this guy is going to switch with this guy.
Because of the charges.
Yep, now you actually have to switch them and write down the charges to see what it is, but we can do those real quick. We can break this down to H plus and Cl minus, and this is Zn2 plus, because it says right here in Roman numerals use Zn2. So then when we switch them, we get Zn2 plus and Cl minus, and H is part of Hofbrnickel, so it's never going to be H by itself. It's always going to be H2, because it's a diatomic molecule. Now we do the crisscross, and that's how we get the ZnCl2.
Okay.
Now for this single replacement real quick, sodium is Na plus, magnesium is Mg2 plus and Cl minus. Our magnesium and our sodium switch places, so we get Na plus, Cl minus, plus Mg. Good? All right. Awesome. Do you want to look at a double displacement one too for how those switch?
Yeah.
All right, we'll start down here with the blank ones first because it gives me more room to work. I almost think the double displacement ones are easier because with double displacement, it very quickly shows you what is the cation and what is the anion. When you're dealing with single replacement, you don't always have a cation and anion because in a single replacement, you have that single element. But in a double replacement, everything is a compound. So you can go through, and I'm just going to put a box around all of my cations.
Are the cations always going to be first?
Yep, cations are always first, right? So I put a box around all the cations. That's the only thing that's going to switch. If I look right here, calcium has a 2 plus charge, chlorine has a 1 minus charge, potassium has a +1, and CO3 has a 2 minus. I did go through and add all the parentheses to the polyatomic ions, so hopefully that will help.
Okay.
So now we do this, we have to rewrite it where we switch our cations. So instead of CaCl, it's gonna be KCl. K plus 1, Cl minus, and the other product is Ca2 plus and CO3 2 minus. When you crisscross those, both of those end up balancing out, and you get KCl plus CaCO3. If you look at this, you see how it's very similar? The Cl is still on this side, the CO3 is still on this side of the plus. You're just switching what I put a box around.
And you get rid of the 2 subscript on the Cl because K2 cancels that out or something, right?
Yes.
Okay.
Now, when you are on the reactant side, you can ignore these. The reason you can ignore them is because you're going to tell me what this charge is by looking at the periodic table. This number may change. You see how it did change? You see how this is a 2 right here, but a 1 over here?
Yeah.
So you ignore it because you're not worried with how many you actually have. You're just worried about what the charge of that element is.
Okay.
So you don't care what's written. You care about what you're going to write on the other side. You only worry about subscripts on the product side, and that's with the crisscross method.
Alright.
Now over here you have H2, right? And I'm going to write this below it because I have more room. H has a charge of what?
+1.
Now SO4, you can get that charge by looking at your naming compounds worksheet, and it has what charge?
Minus.
2 minus. Now this is, you know how I said ignore those subscripts? When I say ignore them, I mean don't let them confuse you. They don't deal with the charges, because what you could have done over here with those subscripts, they can be useful. I call this the reverse crisscross method. I take that 2 up here, and I take this 1 up there.
Alright.
See how that's a reverse crisscross? Because when I were to do it right here, it would be H2SO4. So when you're splitting something apart, you can do a reverse crisscross. When you're combining something together, you use the crisscross method. And I try not to use crisscross too much because I want you to understand that all you're trying to do is make it balance. If this is a +1 and this is a 2 minus, how many of these do you need so that it's equal?
You need 2.
You need 2 H's. For some people, that is so much easier than the crisscross method.
Yeah, that's what I was thinking.
Yeah, absolutely, and please do it that way. Alright, so we have H plus and SO4 2 minus, and now over here, our K is going to have a +1 charge, and our OH is going to have a -1 charge. Now we do our little flippy floppy, we take this cation, and we replace it with this one. That gives us K plus and SO4 2 minus, and the other product is going to be H plus and OH minus. This, of course, is going to be rewritten as H2O. And then how many Ks do we need to balance the whole thing?
2.
K2, SO4. So we kind of covered a lot, which I hope when people watch these videos, they'll notice that it answers a lot of questions they have. But the question we started with was, how do we know what to switch? You always switch to cation, which is written first.
Okay.
Any other questions on that?
I don't think so.
Sweet! We're going to stop the video then, and hopefully everything worked out pretty good with it. Hopefully you didn't make it too long that I can't fit it on the Moodle. We'll